Go. All right, so today we are looking at graphing relationships, okay? This is where we're going to start with the new unit. It's going to be a whole lot about graphing and looking at it and kind of telling a little bit of a story, all right? So that's really kind of where the intro is today. So here are the objectives, is to match simple graphs with situations. So that means you'll be given a situation, you've got to look at it, come up with some of the ideas, be able to describe it and attach those things, okay? Here is some of the vocabulary that we're going to get as we go through this, continuous and discrete. All right, so let's go ahead and go. All right, so I take a lot of this stuff out of the notes, but this is really good, so I wanted to read it to you. Graphs can be used to illustrate many different situations. For example, trends shown on a cardiograph can help a doctor see how a patient's heart is functioning. To relate a graph to a given situation, you use keywords in the description, okay? So what that means here is this is going to be one of those scenarios where you've got to look at something, words, and figure out what it's saying and try and tie to it and then choose the best descriptor for it, okay? So here is the first example. Now, there are several different things that go with this example, so we're going to take it a step at a time. This will deal with me talking more, so I need you to make sure you don't zone out just because I'm talking a little bit more. All right? But here's example one, relating graphs to situations. It says, each day several leaves fall from a tree. One day a gust of wind blows off many leaves. Eventually there are no more leaves on the tree. Choose the graph that best represents the situation. Okay? Now, this is a PowerPoint, this is a slide. There are several types of things that we're going to do here. But notice, looking at this, they give us how many different graphs to choose from? 3. They give you graph A, graph B, and graph C. And what they want you to do, and what analyzing all these graphing relationships are going to do, is you're going to have to look at the words and come up with a scenario that makes sense. So, here in A, to me what it looks like in A is you have some leaves, more leaves get on there, then nothing happens for a while, and then they all fall off. B, it looks like you got some leaves declining steadily, then there's a short drop, then it goes back to declining steadily until you get to the end. For C, it looks like you had some leaves, big, sharp, and a drop. They stayed the same, big, sharp, and a drop. Okay? Now, the next thing is you want to look and see and choose which one to do. So here's what you got to do. You can see step 1 down here below. It says to read the graph from left to right to show time is passing. The reason that you know from left to right is time is passing. Time is the x coordinate or the x value. Okay? It is all your x coordinates. Are y'all with me? That is step 1. Okay? All right. Now, step 2 is you want to list keywords in order and decide which one the graph shows. So, from the description, here are some of the key words. As it says, each day several leaves fall. Well, that means that the thing is never horizontal. It's always constantly moving down. That is a key word. Okay? Now, some other key things that happen is they say that the wind blows off many leaves. Okay? Well, if it blows off many leaves, that means it's going to be a sharp downward because we're losing leaves. Are y'all following what I'm saying here? Okay? So slanting downward rapidly, and then eventually there are no leaves. Well, that means it'll eventually get to the point where on the y-axis, where the leaves are represented, there is nothing there. Now, I don't typically fill this out completely. What I like to do is highlight keywords or statements. But notice here in these notes, they also tell you, hey, well, graph B has this, graph A, B, and C have this, graph A, B, and C have this. So what they went through was analyzed which one has which part. Now, obviously, if you do it that way, you want to choose the graph that represents all of your major events or your major keywords. Are you with me? Let me see. Okay. So, as you come here, step 3 is to pick the graph that shows all of the phases in order. So, here you can automatically tell which graph is going to be the perfect one. Well, it's going to be graph B, because if you go in order, it said that it started by having a few days where leaves were falling. So that's going to be this red section where they just kind of fall constantly for a couple days. Then the slanting downward rapidly was where that gust of wind hit us. And then after that, it started again, just falling at an average rate each day until eventually you get down here to 0, where there are no more. How do you guys feel? Okay. When you stare at me blankly, I'm assuming that means we're good. Okay. So it feels like y'all are good. It's all about identifying scenarios and working through them. Okay. So let's look at example 2 together and continue on here. What it says here is that the air temperature increased steadily for several hours, then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that represents this situation. Okay? So step 1, again, time is on the bottom. So as we read this, we go from left to right. Got to go back for 1 second. The graph that represents this would be which one? C. That is 100% correct. C would be the best answer choice. Okay? Now, again, this one is kind of laid out for you where it goes through some of those key phases. Some of the key phases were that it increased steadily. Well, if it increases steadily, the word increasing means going where? Up. Now, when it says remain constant, this is something that might be new to you. If there is no change in something, that means it doesn't go up and it doesn't go down. But does time stop? No. Time will continue on. So that is when a horizontal line comes into, because it's not going up, it's not going down, it's just staying the same. So horizontal lines mean things are going to stay the same. Okay? And then it says it increased slightly before dropping sharply. So that means it's going to slant upward a little bit, and then it is going to drop straight down. Okay? Now, this one's a little bit easier for some students, these examples, because if you look, I'll be honest, it does a whole lot of work for you, where it tells you what is represented for each one. You are going to have to do this on your own. Okay? We are going to get there. I'm just going through some examples. So, as you look, and you would have chosen these, and the reason it is the best answer choice is because you know that it talks about increasing rapidly, then it's got a horizontal section, but then it goes up and then comes back down. So again, C was the one that kind of looked like this. It increased. Ooh, whoops. Let me go here. It increased, it flattened, it rose, and then it dropped straight down. So that is what C looked for. That is what it was. Okay? You can see how to do it. Okay? Now, let's go in here and get some of these definitions down. Okay? As seen in example 1, some graphs are connected lines or curves called continuous graphs. Okay? So a continuous graph is a graph that is always connected. That means there's no break, there's no dot. So looking at a graph, it's always got connected lines. Okay? But there are also graphs that have distinct points, which we call discrete graphs. Okay? Now, here, if you look at this example, this is an example of how a discrete graph could look. The graphs on a theme park attendance is an example of a discrete graph. It consists of distinct points because each year is distinct and people are counted in whole numbers. Okay? So when you look and talk about things being discrete, they typically end in whole numbers. Like, for example, if I was counting the amount of caterpillars born in a day, could I ever have 2.5 caterpillars born in a day? No, you can't have half a caterpillar, no matter how big or how small the caterpillar is, okay? It's got to count as a full caterpillar. So that would be an example of discrete, because it could be 2 this day, it might be 3 the next day, okay? Those are the things right here. So you can see right here, and this does a great example of it down here, all right? Right here, it says it consists of discrete points because in each year it is distinct and people are only counted. The values between numbers are not included since they have no meaning for the situation. That's why a discrete graph, it goes from dot to dot instead of a connected line. Okay? All right. Now, here is this next situation. Okay? So, looking at this graph, we're going to go through it, and here's what we want to do. We want to tell whether the graph is continuous or discrete. Okay? So, here's what you need to know. A truck driver enters a street, drives at a constant speed, stops at a light, and then continues on. Okay? So, looking at this graph, is this something that is considered continuous, or is this something that is considered discrete? It would be continuous. That is correct. So you should have hopefully chosen continuous, okay? And the reason that you know this is continuous is all the lines are connected, okay? Now, I want to go through something here because it also helps you understand when it comes to drawing a graph or reading it. Notice this first red section on mine right here. It says the truck driver enters a street and drives at a constant speed. So this red line is him entering, okay? And then this blue line is him driving at a constant speed. Okay, now, what do you think the green and the purple represent? Yeah, it shows him coming to a stop and then starting back up and continuing on. Okay? So, good. If you were seeing that, you will be good to go. Now, here's a helpful hint. When sketching or interpreting a graph, pay close attention to the labels on the axis. That's important, all right? 9 times out of 10, when you talk about time, that's going to be your X, okay? And then the thing that is changing is going to be your Y. All right, so let's continue on. So, right here, they ask you to sketch a graph for the situation, tell whether the graph is continuous or discrete. I went ahead and sketched the graph for you, okay? It says that a small bookstore sold between 5 and 8 books each day for 7 days. So, notice here some big things to look at. You've got books sold, which is your y-axis. The number of days, the time, is your x-axis, okay? So, they sold between that for these 7 days. So, I took that information. Well, what we've got to decide, is this discrete or is this continuous? Huh? Okay, I do not agree with continuous. If it were to be continuous, what kind of line would I have in my graph? It would look like this. It would be connected. Is this line connected? No, it is not. Okay, huh? It was because I drew over it, but now it's not. These are separate dots. That's what makes this discrete. It is discrete because day 1 is separate from day 2. Day 3 is separate from day 4. Now, here's the other thing that makes it. If you're selling books, can a store sell you half a book? Can you be like, hey, I want to get half of the first Harry Potter book? No. You got to buy the whole daggum thing. So also in these are whole numbers represented on our y-axis. We also don't care about how many books we sold halfway between day 3 and day 4. That's why they're all separate, and it is discrete. Okay? Here's another one. Sketch a graph for the situation. Tell whether the graph is continuous or discrete. All right? Here in the situation, again, on these notes, I've given you a lot of these graphs just to speed up time. Jamie is taking an 8-week keyboarding class. At the end of each week, she takes a test to find the number of words she can type per minute. She improves each week. Well, is this continuous or is this discrete? Why is that wrong? Yeah, okay, so here we go. So let's talk about it. Yes, what you just talked about could be continuous. If you could have, hey, how many per minute, how many words per minute? If we were looking at how long she was typing, yes, that would be continuous because she could go 24 minutes and 5 seconds. But what are the things we're looking at? We're looking at the number of words per minute, and we're looking at the number of weeks. Okay, if I'm typing, have y'all all taken a typing class before? Okay, if you have not, I remember taking one and you had a book right here and you literally had to sit there and look at it. I'm sure in today's times they have something on the screen where you can just look at the screen and you have to retype stuff. But we would do a test like this where our teacher would say go, and we would sit there and type. If you didn't finish the word, guess what? It doesn't count. You only count completed words. So that means you can't have a fraction of a word. Also, we're looking here every week. We're not looking every day. So our time is mapped out by weeks, and then we know our minute have to be complete words. That is what makes it discrete. Okay. All right. So let's continue on. I'm going to give y'all a second. Next one on your own. I'm going to give you 20 seconds. Ready, set. Okay, so looking here, sketching this graph. As you look at this, Henry begins to drain the water tank by opening the valve. He then opens another valve, then closes the first. He leaves the second valve open until the tank is empty. This would be an example of it being continuous. Now, how you knew that without me even saying anything was that it was a connected line. Okay? So, we are going to try to go there. All right, now, this next thing is it says both graphs show a relationship about a child going down a slide. Graph A represents the child's distance from the ground related to time. Graph B represents the child's speed related to time. Okay? So, you've got both of those there. Look, know about this one so far. This is the relationship of a child going down the way. At those. Okay, now, write a possible situation for the given graph. Okay, so step 1 and 2 are the big things about identifying what is being asked. Okay, this is huge for y'all because now it's the opposite. Instead of me giving you the situation and you graphing it, now you're given a graph and you've got to come up with the situation. Now, if I don't give you any parameters, run with it, go wild. But what do we slide? Okay, so as I look at this example here, step 1, you have to identify your labels. What is the x-axis? Well, in this picture, the x-axis is time. The y-axis is speed. Okay. Now, step 2, you need to analyze each section over the time and the speed. So, there are 3 sections here that are color coordinated for you. The red section, what is happening? Yeah, I would say it starts going down. Okay? What happens in the blue section? It's going the same speed. So starts going down and then it maintains speed, or you could say starts going the same speed. And then what happens there at the green? Yeah. And then it drops speed until ride is over. So you see how all we did right there was kind of go through it step by step. Okay, now, I'm not going to require you, if it's something like this, to write out a big long paragraph. You're more than willing to if you want to, but I'm not going to require that yet. If you can describe it writing next to it and I can read it, then that is perfectly fine for me. But if you were having to write this as a given scenario, you'd say, okay, well, at first the child gets on the slide and he starts going down and it picks up speed. Then it maintains his speed through the ride, and then he gets towards the end of the ride and he starts to slow down until eventually he stops because the ride is over. You see how something like that went? That's what you would be asking to do. All right, now, I want to do another one right here with you on 18. Another one right here on 18, and then I'm going to talk to you about what the rest of class is going to look like. Right here, I want you to write a possible situation for the given graph. Okay? Well, the first thing I notice is the graph connected. No. So these are going to be some kind of discrete graph. It's going to be something like that. Well, let's find our axis. What is the x-axis? Students. What is the y-axis? Pizzas that were bought. Okay? Now, the next thing we need to do is analyze and come up with a situation. Okay? Well, here's what I know. To me, this looks like, hey, this student bought one pizza. 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 Uh-oh, what happened next? How many pizzas did this student buy? How many did this one buy? 2 and 2. So you've got to come up with some scenario. Here's the scenario that I would say. The camp was selling pizzas. The first 4 students each bought one pizza, and the next 4 bought 2 pizzas. And that's that. That's simply looking at the graph and looking at the information that I was told and writing a scenario. Now, is that the only scenario? No. You could have said, hey, at a camp there were 8 students that bought pizza from the camp. Out of those 8, 4 students only bought one pizza and 4 students bought 2 pizzas. I mean, you could even come up with another scenario. Hey, there were 8 total students in line to buy pizza. However, 4 of them partnered up with somebody else to buy 2 pizzas. It's your imagination. There's not a wrong answer as long as the information that is shown to you is represented in your scenario. All right, here's what we are going to do. The last 2 examples are for you to try. I've also got a quick practice sheet that's got 4 problems on it, okay? Those 4 problems, I'm going to give it to you here in a second, are a scenario type deal, okay? You're going to be given a scenario, and you're going to have to, or in a graph, and you're going to have to write and answer some questions about it. This is practice for you. I just want to see how well we can do with this. All right, ready, set, go. Okay?